My name is Angela Trentacoste. I'm the Smith Senior Fellow in Archaeology here at the British School. And it's my pleasure to introduce tonight's keynote speaker for our conference on a critical approach to mobility in the past. Luca Bondioli is a biological anthropologist and paleoanthropologist, adjunct professor of bioarchaeology and prehistory at the University of Padua, and a fellow of the Polish Academy of Sciences in Krakow. For more than 30 years, he directed the bioarchaeology service of the Museum of Civilization in Rome. His main interests are advanced methods in skeletal biology and the application of histology, geochemistry, and statistical methods in archaeology and anthropology. And for those of you who are online joining us, we have been hard at work here since 9:30 in the morning, stretching the frontiers of bioarchaeological approaches to mobility. And so you're joining us at the end of a day, which Luca will be, I think, wrapping up and expanding. But it's my absolute pleasure to have him as the anchor of our proceedings today. Thank you very much, Luca.
Okay, good afternoon to everybody. I'm very happy that you are surviving this very tough day, and welcome to other people that are online. Look at me. First of all, as obvious, I have to thank the organizer of this workshop who invited me to give this keynote. But because I tend to be very honest, I have to tell you that I never been invited, because I was there when they were discussing to organize this beautiful workshop. They simply told me, you do the keynote. And that's all. And so here I am. I'm not so sure I will be effective to do it, but let's try to do it. Particularly why I'm not that sure. Because as you see, if in this slide that I used to show very often, there are no isotopes. This is the story that summarizes my scientific career. And in the cloud, there is remain, modern, human, enamel, study, but no, the word isotope is not here. And why I am here giving you a keynote exactly for something that is not really my major discipline, because, and the fault is Professor Wolfgang Müller, who gave today a very beautiful talk, who met me, close to 30 years ago. Yes, close to 30 years ago. No, less, 20 years ago. And he fascinated me with possibilities that I never have thought could have been possible at that time. But the first thing I want to thank is this beautiful substance that we call apatite, or biohydroxyl apatite. We want to be more, let's say, more formal, who is inside all of us, and which is so important for the study of the past. Why it's important, this nice substance? Because it's always the same thing. The geochemists, they can tell you that is not in peculiar, strange things, but for different reasons that, to be honest, I don't understand really well, is very flexible as a substance that can take all the possible shapes. It can be a skeleton, it can be the shell of a snail, it can be the enamel. In our mouth, there are teeth, and teeth are so incredibly different in structure, microscopic and macroscopic, but they are made of the same substance. That is, at the end, bioapatite. And bioapatite is the key we use for open some aspect of the past of our communities. But everything you pay, let's say, cost. bioappetite is slightly like Mephistopheles. You start working with it, but they ask a price for what you are doing. And the price is that what we think about bones, for instance, particularly bones, is not always true. There is a famous story, bones don't lie. That is not true. Bones are true liars because what they are programmed, they are done not for what we want to use them. So as, let's say, time machine giving us back information about the past, but they are built to support us for our metabolism or whatever you want. And we use them and they don't, and bioappetite and bones, they don't care if they are saying the truth or something wrong. And we know since, I think, 50 years, that problems with the analysis of the bones is very, very, very important and common. And now I show you what I always show, so many of you have already seen this. This is my feeling constantly. Hope there is no one here, Scott Origins, that could be offended. But anyhow, I am in the middle. Okay, not this fascinating person, but I am in the middle. And a lot of important things are trying to make my life more difficult, not so easy. And they say the farewell to paludemography, because when I was young, paludemography was one of the most important subjects in bioarchaeology. Now it's a very peculiar, strange aspect. The astrological paradox that at the end states that we will be never able to fully reconstruct the epidemiological profile of any population, regardless if modern or old, because we are not able yet to know things that are difficult to be known, like the individual susceptibility to illnesses or the individual, let's say, susceptibility frailty. So if we will die sooner or later. I always speak about my father. My father is 101 years old. He is in very good shape. And according to my definition of frailty, he should have been never alive at that age, because the frailty of my father is unbelievable. A lot of heart attacks. He went to prison in Germany and so on. But he should have been survived so long. So the individual survivorship is something that mock us a lot when we are reconstructing the past. And then the archaeology. I'm not an archaeologist. I don't pretend to be intelligent to be an archaeologist. But the archaeology, this you see how she look. No, excuse me, I did the wrong one. Okay, she's looking at us, hoping to have answers, but the answers we are able to give back are not so good as we want. In fact, what is the title of this workshop? I read it. So close and yet so far. So they are close, but not so, but not that much, but they are still far away. A critical approach to mobility in the past. When you say critical, by definition, you start saying there are problems. If you're a believer, you are not critical. If you are not a believer, because we are scientists, we are not believers, we always have a critical approach. So what we expect and we had here in this workshop has been problems, but thanks to the God of science, we had seen some possible solutions. Again, my word is this one. I'm coming because in the 70s, I was studying at the universities. I'm coming from a discipline that relied only on morphology. So we tried desperately. There are other. There is Alfredo around here who was with me. We were trying to extract from the morphology of the bones information about our evolution, and we are doing still, because of course when we are speaking very far in the past, morphology is the only hope that we still have to reconstruct the past. But then an incredible kind of revolution appeared, and something that we would have never thought would have been possible, like the ancient DNA analysis, that today is so widespread that everywhere you find hundreds of sequences available for the past with the constraints in time, in nothing older in reality than for 100,000 years before present, but they give us information that is impossible. And the new one, I will discuss later a bit, the possibility to reconstruct the kinship and the relationship is opening an incredible new world of information. And on the same, what the isotopic signature in the past population is something that when I started, even if I am a biologist, even if I made many courses in chemistry that I forgot completely, isotopes for me till mid-90s weren't something very far from what I was able to see. But at the end, now here I am discussing with you isotopes, provenances, and strange things like isoscapes and so on. What is important for me is that this new kind of disciplines, this new kind of information are very linked with the individual life history reconstruction approach. I strongly believe that we started long time ago discussing population. So we found a graveyard, we excavated the graves, we collected all the skeleton, and then we started to find the trends, the means, the variability of a population, more than the story of the single individuals. But this is not wrong, but can lead to some misunderstanding, because populations, group, any kind of in this kind of humanity is made by single individuals, single people. And so we have to do our best to merge the two information, populational one, because when we are speaking about Etruscan, we are not speaking about the single Etruscans, but when we are speaking about Fermo grave number 17, we are speaking about a specific individuals that carry some information that are important for us. So to make it short, that is, I don't know if it is, I listed here the masochistic approach to mobility in the past that has been discussed here. So I listed a number of possible problems that we have in using the study of mobility in the past. Some of them has been faced today, but I want only to give you a general idea. For instance, the big problem is that what does it mean to be local or non-local? Because we are using a dichotomous, we cut a reality that is continuous. It's not easy to define if a person is local or non-local. Okay, I was born in a place where I wasn't born. Okay, this is non-local individual. But what happened in between birth and death is what we want to know. So cannot be, and we need maybe a more nuanced definition of mobility. But more nuanced definition of mobility implies more problem and things less clear. We have the problem of inhuman and cremated remains that thanks from a group of people, of researchers, they did a lot of work, particularly Christos Nook, that he's here with us, who worked a lot and solved what and made rejuvenate this kind of beautiful specimens. They are the cremated individuals that I used to call then the hell of the bioanthropologists. Then now they are no more the hell, but they speak a lot. The problem of determining provenance and equifinality. So because there are many places on the Earth, they have the same isotopic signature. So how can we discriminate the possible provenance for the individual? The fact that we need to do multi-sample approach, not a single sample for one individual, but when possible, more than a single one. We need to start using high resolution approach. High resolution approach means trying to reconstruct the life history of one individual. The problem that our host, Angela, knows more than anyone else of the very complicated relationship between humans and animals. And to try to, we are not so interested in animals. We are interested of the humans, they use the animals. Like the animals, as says my son, are machines where domestic animals, you put bad things like grass and leaves, and you have back butter, milk, and meat. That is a beautiful machine. It's one of the best machines ever invented, but the relationship with them is very complicated and speaks a lot about the social past. The terrible enemy, diagenesis, that makes everything more complicated and very often meaningless. And most of all, we have constantly to take into consideration archaeology and history and bioarchaeology, because we cannot think now we do DNA, ancient DNA, and we do best isotopic study, and we don't understand nothing about what they were, and we need archaeology and history. There is a very nice story that my good friend Alfredo, who is over there, told me a few years ago. He was in a PhD committee where they were describing the DNA of a plant. And I don't remember the name. And so at the end, this very good candidate made a very complicated, difficult history about the evolution of this plant and so on. Alfredo, who is like me, coming from a different school, and then made a question. So, but this plant, what it is a shrub, a grass, a big tree. And the candidate wasn't able to know. He never looked at what was the plant. So we have always to start from the archaeological evidence, even if not perfect. We have to start from the bioarchaeological evidence, even if not perfect, because only through the lens of bioarchaeology, archaeology, and history, we can really understand what we are doing. But these are words. So our organizer, very nice, made this panel of people discussing the different critical approaches. And I will try to summarize the problem that I don't remember all of them because I'm old, but I will try to summarize what they said and to put in a perspective of what can be done. And to make it simpler for me, I decided, maybe I was wrong, to build an avatar. So a fictitious person, that is myself, and I called it the Isobond avatar. The idea of the archaeology of self, even if developed long time ago by Alessandro Vanzetti, Massimo Vidale, and and Leonardi went back to me thanks to a young collaborator. Her name is Jessica, who arrived to me. It was, I don't know, a few years ago. And at the end of the lesson, he arrived with a small container of glass and said, "Here I have all my deciduous teeth. I want to study archaeology with them." It's a great idea because now we are working with her, and this made things simple because you need to understand on yourself maybe. And so what I did to make this avatar, I was born in Milano. And my family used to deport me, I have to say deport me, till age 18 for 4 months a year in the mountains, because the rule was we do vacation in mountains. And I use as isotopic signature the beautiful tool by Federico Lugli that you can find online, where you put the coordinates and it gives you more or less, no, a 50 kilometers or even less radius isotopic isoscape, and you estimate where you are. Then I took my degree in Pavia. So I moved from Milano, that is at the beginning of the Po Plain, deep in the Po Plains. And then after my degree, I moved first to Chieti, where I spent 6 years hard, and then to Rome, where I am still here. So if I have to model my isotopic history, it's very simple. What I have? No, excuse me. I was born here. Each 4 months, 8 months a year, I was in the Milano, that is here. Then I moved in a much more radiogenic because it's close to the Alps. It's at the, it's not that far, but it's a very cold valley in northern Italy. And so I did this up and down, up and down, up and down, up and down. Even when I moved to Pavia, which is different from Milano, but not that much, I continued, but for a shorter time, till I immigrated to Abruzzi, here. And I stayed there for reasons I prefer not to remember, for 6 years without moving from there. I wasn't alone, Alfredo was with me. Then I moved to Rome, and here is my life till now. This is the model of my, let's say, isotopic story. It lacks the last moment. The last moment is very important because the most important thing that we get from the individuals in a graveyard is that we know where they have been buried. So I don't know exactly if, as a dead person, I will go in my family graveyard, northern Italy, or I will stay in Rome. But this choice is not mine. My wife, she will decide. She's there. But as we will see, this choice will make completely different interpretation because we are not able easily to recognize where one person died, but we know for sure where it was buried, birth or inhumed, but is something there. Unless they will throw all my ashes in the sea, that could be a possibility, or in the Ganges River. If in a normal Italian way of life, this will be the problematic. So the organization of the today workshop started exactly with this, because Alessandro Vanzetti, archaeologist specialized in Bronze Age, if I'm not wrong, that I know since many, many years, gave us an important critical reading of the available literature about provenancing and interpretation. And this has been very important to start with this, because he showed that the interpretation of local and not local dichotomy and the identification of the provenance is deeply linked with the ideology of the person that studied this kind of evidence. And this is normal. All the science is constantly with people, they don't see what they have in front of them, and they see only what they believe it is the truth. I have my personal experience, I don't tell you, but for instance, is when I decided that it would have been that I found the right pelvis fragment of a Homo erectus, for 1 month, I decided it was right. It was left. But I wanted to see it right. So this is very, because we are humans. We are humans. Our thinking is not so scientific as we want. We would like to be very scientific, but the emotional thing is always playing with or against us. The second talk, I will not discuss in the order that's given. I made my personal list, was Richard Magdwich. I never understood how to pronounce it correctly. But anyhow, he showed us important thing. He showed us that not only strontium isotope is bracket, strontium isotope is the best preferred tool for studying mobility in the past. Okay, he showed us they are different. There can be you can use sulfur or you can use lead, but the idea to have more proxies is very important, because, as I told you, if you mix up different level of equifinality, so I'm coming from here, but here, maybe here, but here I don't have the correct, let's say, lead signature I found it, maybe I have to find something somewhere else. So it's very important to have multi-isotope approaches. But because Richard, for the little I know, is a very serious researcher, he was very problematic and showed us that when we see some behavior of the data, we have to think a lot why it is. And he showed us like model contamination can completely affect our interpretation of the data, particularly for sulfur. And that lead, which is a very difficult isotope, according to my geochemical colleagues, to analyze, is working really better, but the problem of pollution is very strong. And pollution by lead is something that is important. Wolfgang Müller asked me to work on it since at the beginning, but I said no. And now I am working a lot because he was right. But one of the typical things of my life, I worked with people, they were right, while I was wrong. But this is normal, again, a normality. After that, even if not, Angela arrived. Angela showed us how it's complicated to raise the machines for producing milk and cheese and meat. How the humans adapted their life in order to have the machines working at their best. And how it is difficult to get out from this complicated way of raising animals, transhumance, local, wind seasonality, going up and down from the mountains. So at the end, the number of, let's say, the number of elements that we have to take into consideration to have a nice picture, a consistent picture, what we want, is not that easy because the humans worked on the animals. Why my good friend Robert Anchevich, he's working with, may I say, hopefully you are not offended, with simpler animals, big one, elephants, mammoths. And with mammoth, we learn a lot because being so large, and believe me, it's a lot of work to work with this size tooth instead of working with this size of tooth, but working with this size of tooth, you can do more mistake easily. You can cut it badly. Then there is another place where when you are working with a tiny tooth from a Homo erectus, if you do it wrong, this is a problem. But at the end, he showed us how it is possible to reconstruct using the large molar teeth of mammoths. It's important to use the molar teeth because the few other publications about this kind of work, they didn't use molar teeth, they used tusks, but tusks are made of dentin. And dentin is close to be an enemy. Why? Because enamel, again, hydroxyapatite. Apatite, not special, but it's very hard, very well packed. It's a very strange, in my opinion, thing where crystallites are oriented inside a very complex matrix and tend to preserve the signal. Dentin, no. Dentin is like a sponge because it's made more or less with a very well-ordered sponge. And like all the sponges, it absorbs everything from the environment, particularly from the environment where the individual died. And so more easy to read diagenesis than enamel. But results are beautiful because I think a little because Robert was lucky. It was possible to read perfectly seasonality. So wild animals are, I think, simpler than the domestic one. Angela did a mistake working on domestic animals, simpler with the wild one. Because here, even if there is some evidence of the human activities, is not so strong. Moreover, to impact on such large animals is complicated. But very important, we learned a lot from this kind of analysis because we were able to reconstruct the life history. So today, for the first time, Robert showed us the life history of an individual. 11 years, we don't know exactly, winter or summer or something like that, that moved around what is today Poland and Ukraine and Czechoslovakia. And while moving, they changed their isotopic composition in the Another very nice, interesting talk was made by Federico. Federico, who demonstrated today two things. First, that art and science, they go together very well because the so beautiful maps is difficult to see. And he showed us how it's important to have the map of distribution, what we are expecting from the isotopes. And this is Italy, okay? And you see the problem immediately. Everything that has the same color is the same signature, so equifinality. And maybe, I asked him to do it, but he said it's not as easy as you think. Why we don't, this is strontium, this is oxygen, this is, I don't read it. Maybe, no, I don't read it, I'm blind. So at the end, it will be nice to have a very granular, because it will be a very coarse map of superimposition of the different isoscapes. But he told me it's not that easy. Why do you think it's not possible? Yeah. Okay. Oh, I am not. I'm not a Joachim, so I can say my wishes. Okay. Then Christoph Snook, very nicely, that we love him for our cremated bones. I put here some cremated bones, but gave a beautiful presentation telling us, okay, but your isotopic signature is what you eat. If you don't know what you eat, your reconstruction is a little complicated. And you can do many mistakes because you don't know exactly what is the composition of your food. For instance, he showed us that what we were expecting, the difference between people eating mostly vegetable-derived food or carnivore is not always the result what we expect. We expect omnivore and carnivore. But, and we have a real example here with us, if the person who is not carnivore, but she was Alessia, ate only during pregnancy, ate only pasta, let's say, carbohydrates, and no vegetables, then at the end, the signature is not that different from a carnivore. So it's not easy to understand the trophic label. And at the end, this beautiful picture that showed us what will go, and our expectation is still with the most important systematic about strontium is still when in our expectation, still with a lot of trouble. While the poor oxygen is a lovely thing. We are alive for him, and we die for him through oxidation, but it's declining in our expectation. So go ahead. Then Wolfgang introduced the idea to work with high resolution. So to reconstruct on teeth, because we can do only on teeth, how many minutes I have? Oh, yeah, plenty of time. And it's possible to see things across the individual lifetime. That's very important because with high resolution, here, what does it mean? Take an individual teeth, one or more teeth, cut them, do the histology, and use a very sophisticated machine. For me, it's very sophisticated, maybe for other scientists, not that much. Very sophisticated machine with laser beam, like this one, going through along in the enamel and reading the chemical composition and isotopic composition of it. But this is the future, in my opinion, but it's difficult. No one said this, but as far as I know, and now I say it openly because I'm old, I can say what I want, while there is plenty of labs in Europe, US, Africa, Asia, where they're able to do a very good job in determining strontium isotopic composition in solution, so sampling it, to do a very precise and good laser ablation analysis. I think the labs in the world that can do it easily on human teeth are less than the finger of a single hand. And this is a problem, because if we are proposing this method as a good one, the perfect one, it costs. It's difficult. And we cannot overwhelm those 5, even less, lab with thousands of specimen. And Alessia gave this presentation trying to compare the bulk analysis. So you take a tooth and you drill it, and you analyze what has been drilled. I don't know the past of drill, what you have done with laser ablation. And the difference is huge because, for instance, is because we have to use teeth. Teeth are our major, the better substance. The evolution in terms of time it's not linear. This, for instance, it's a single tooth. No, it's not this one. And we draw each band correspond more or less of a fixed period of time. So this formed along this period is being formed between in 504 and 54, I don't know what days. So each band corresponding, I can call it a chronoscape of a tooth. That is very important because it's not easy to sample in a so complicated thing. You can do by laser ablation, but it's complicated. And results are tend to be completely different. Okay, moreover, there is not so perfect the relationship between laser ablation and bulk analysis, but it worked, for instance, in this specimen from Fermo. Then, for me, one of the most important things, because we moved from isotopes to ancient DNA. When I think this is very important, it's another word. Ancient DNA has very little to do with isotopes, but only if we work all together. And Francesco Fontani told us that there is a paper coming out exactly like this, moreover, but we have other evidences. Ancient DNA today can tell you not only the ancestry. My ancestry is mostly Central European plus some Sicily. That's my ancestry. But it's possible to reconstruct, if you have them, the network of kinship. This is incredible. If we are able to reconstruct the networks of kinship in past population, in my opinion, we are building a new metric for the analysis of the past population, because we can take two samples, compare the number, reasonable, of course. I don't know, Yanomama with people from Alfedena, I am expecting no kinship. But if you are but Alfedena people, they have kinship everywhere in Europe, by the way. If you're able to measure the kinship, you understand how they are closed and how they move. And so he showed us how it is possible today, till the 6th grade of kinship, to reconstruct, regardless in reality, even if he doesn't agree, the real space distance, the movement, or in terms of kin. And that is very, very important. Then last, Carmen showed us a way to mix up all what I've shown to you, DNA, archaeology, high resolution, HDNA, and she made a reconstruction of what's happened in some early Etruscan sites in Italy that is credible, interesting, and as far as I know, never seen at this level of detail. And so this was the last talk that summarized everything. And at the end, with all the difficulties, there is a lot of hope. Because, as I was saying a few minutes ago, when I was your age, anything we have discussed today was simply a dream, or even so difficult that it was not even a dream, was something maybe, we don't know, impossible even to think that could have been possible, and it happened. So in your future, not in mine, unfortunately, will be the same. What the difficulties, what we have seen today, now we go again back to the avatar, will be solved, I don't know, for isotopes with special kind of new techniques, very fast and very efficient and not costly. The DNA will be much more easy. Then we will have a gun and we shoot on a bone and we will have the kinship, I don't know of what. So we will have what we want. But today, the situation is not as simple. This is, again, my avatar, the isobond. We can use only the enamel. So if we do the so-called bulk analysis, the 3 molars, means from age 0 to age 13, will give exactly the same message, because my deportation in the Alps was very precise. We start the 1st of June and we are back the 1st of October. Nothing changed all my life. And what we will have doing high resolution is not exactly what we have seen. That means these beautiful peaks, 4 months, 4 months, 4 months, 4 months. So, but it's completely different, is maybe an approximation, because the problem, one of the problem not really understood yet, is how long it takes from the local signal through the food and the water to enter in your mineralized tissue. How long it takes. Our experience, for instance, it has been shown by Alessia, can be very fast, in a few days. But other examples made on moving ships from Mongolia is different, much more time, longer time to fix the local signal inside what are our let's say, mineralized tissue. So even if I do high resolution, I will have this situation. Let's go back. A weathering. So seasonality. But the signal of seasonality will be present. The problem is we can use only the teeth, only this little amount of time. What's happened after each 12 is completely, definitely not understandable. The only thing that could help is Francesco, because my ancient DNA maybe will find more relatives in Rome or in Valganna. They will find in Valganna. And so what will be the interpretation of myself? If I will be buried here, I will be a local person with a lot of seasonality. And I was a shepherd, of course. Of course, why not? Going up, why should I go up and down the mountain? For fun, as I did. No, because I was a shepherd, of course. But if I'm here, because you see that Milano is not that different from Rome. It's not that different. Chieti will disappear, cross. Pavia will disappear, cross. And they will say, oh, maybe there is a problem. And so he's a shepherd, but from Rome, going up and down on the Apennines, and nothing will change. So I have 5 minutes more or 2? Okay. Last question. The problem that everything we do is destructive. We do DNA, isotopes, stress element, whatever you want. You have to take your specimen and destroy them. This is a big problem because I was a museum man, so I understand perfectly. Curators tend to say, no, we cannot cut. We cannot destroy. Particularly, the most wrong thing that is said, because maybe in the future will be better methods to do the analysis. Of course, they will be. But if we don't do it now, the better will never arrive. So we have to sacrifice something for a future that we hope will be, but it's not so sure. And so the problem is to cut or not to cut. This is the problem. And I am in the party of let's cut them. But I understand people, they are not so willing. So we tried to find a way to minimize the impact of destroying and preserving, at least partially, the morphology of the sample we cut. Of course, it's not perfect. Very often we do mistakes. I vividly remember when it happened to me to do the high resolution replica of a Homo erectus 1 million years ago from Eritrea. And I was in front of the general director of Eritrea, and I was so proud. Now I'll show you what beautiful things we do. So I covered the tooth with silicone rubber. Then I took out the tooth, and the tooth broke. I lost 3 years of my life. And I have to say that the general director of Antiquities of Eritrea, who arrived with this beautiful tooth, a lot of ceremonies, and said, it's not a problem, just glue it. If you don't do it, the only way to don't destroy is doing nothing. If you don't do, you don't make mistake. But if you do, you do mistakes. And this is the important. For me, the take-home message of today is we can do mistakes. It's normal. We can do it without any problem. And what is important, and this is very difficult, is to try to merge again the individual, my avatar, my life, inside the group, in what I can call a virtuous feedback cycle. And this is difficult to build, but this is the future, in my opinion, of bioarchaeology. Okay, I'm finished. I cannot, everyone put beautiful pictures of colleagues and so on. I cannot. I will spend an hour discussing how many people helped me to do this. So I thanks all of you for being here, all my colleagues, past and present and future, and thank you very much for your attention.
Thank you so much, Luca. We have some time for questions if there are any online or in the room, although I imagine those of you who have joined us just for the keynote will have the sensation of having been launched onto quite a fast-moving train. If any of our, especially if our speakers today have any points they want to bring up. No, actually, I had a question for you that dovetailed a little bit with what we were thinking about today. So a lot of the case studies you presented in this talk, and a lot of bioarchaeology in general, is geared at prehistory. And as we move into the historic period, do you think that there is something inherently different, or is it just integrating textual evidence as a sort of another line of evidence as the same way we would do anything else?
Prehistory is simpler. Prehistory is much simpler. Why is simpler? Because they don't speak. Prehistory, they left nothing written. So we can say what we want. And then starting from the written sources is a little more complicated because we know even in Middle East how many cups of, I don't know, corn people were paid on is much more complicated. And moreover, as Christoph said, the variability of the food, I think, increased during Roman time a lot. He was showing the use of preserved fish, garum, made locally in Belgium, I think during imperial time. But then it disappeared in medieval time. But in medieval time, the evidence we have are nice, but I still think that after prehistory is much more complicated because I don't know, imagine I did it. I studied that. Ancient Romans. Okay, but what they ate? They had aqueducts, so water coming from everywhere around. They imported goods from Africa. The stuff, the staple food was coming from Egypt, and fish was not so common. So yes, we can say something, but prehistory is much more easy.
Any further comments, questions? No, I think everyone's had a long day.
Yes,
Thank
very
you
long.
so much. Everybody is very, very welcome to join us upstairs for a drink, for refreshment, for conversation. There is dinner for speakers. Thank you to all of us for joining. Thank you to all of you for joining us. And let's thank Luca one more time for this very exciting wrap up.